Yes.
Yeah, I
Everyone
didn't
loves
know
it.
that was the standard nowadays. I was just watching yours like this is
Hey
epic. All right,
guys,
let's
guys,
go.
quiet! My stream's gonna get jealous that they didn't get the Dayton Miller flute intro. All right, I'll have to roll the Dayton Miller flute intro next time. Hey everyone, welcome
Yeah, I
to.
didn't know that was the standard nowadays. I was
Oh,
just
I'm gonna
watching
echo one
yours
second.
like this.
All right, my bad. Hey everyone, welcome to Ether Cosmology Reading Night number 28, something like that. Who cares? Uh, tonight we are reading from Halton Arp's Seeing Red, which is about redshift in quasars and galaxies, and his journey through academia and being essentially rejected every step of the way for trying to be truthful in his endeavors and in his studies. So, in any case, if you want to see where we read previously, you can look back through our previous reading nights, look back for the Redshift videos, or also pick up Seeing Red by Halton Arp. If you're having trouble getting a hold of it, reach out to us. We can help you out. So yeah, chapter 5 here is the local supercluster. Real quick, the typical disclaimer on Research and Reading Night is that this is us doing live reading, live research. And if you want to come join us, you can hop on over to discord.gg/ethercosmology to join us here on the Discord server, where we typically do our reading. And also join us on Telegram in case anything happens here to this Discord server. And you can find both of those also over at ethercosmology.com, and just click on the Discord icon there and the Telegram icon there. And so, yeah, this isn't really a presentation. This isn't really for the audience per se. We didn't put this together to be enjoyable. So if it gets a little bit dry at times or a little bit slow at times, that's just the nature of doing live reading and research. So without further ado, let's hop into some Halton Arp. One of the most dedicated catalogers of galaxies was Gerard de Vaucouleurs. In the 1950s, he began to notice that the bright galaxies fell along a great circle in the sky. He realized that the galaxies were distributed in a flattened disk, and that their strongest concentration was in the direction of the constellation Virgo. We were somewhere near the edge of this supercluster of galaxies, and we saw its center as the Virgo cluster, about 17 MPC, 55 million light years distant. Because it violated their assumption of homogeneity for the universe, other catalogers initially scoffed. But now determinations of supergalactic latitude and longitude are an accepted way of locating objects in the local supercluster. It turns out, therefore, that the Virgo cluster is the center of the largest physical aggregate of galaxies we can study in detail. We will see that it contains the greatest range of types of objects, ages, and energies. It is there that we can best observe a wide range of physical processes and the relation of different objects to each other. In Chapter 3, we saw that the smaller companion galaxies in the Virgo cluster had systematically higher redshifts than the larger, older galaxies. We can test and extend our earlier conclusions about age redshift relations by trying to understand how the Virgo cluster is structured and how it is evolving. One of the most informative analyses is by C. Cottagny and is shown here in Figure 5.1. The upper left panel shows the distribution of the giant ellipticals. M49 is the brightest star at the center of the cluster, and there's a line of bright ellipticals above it. The most interesting panels are the upper and lower right, which show the spiral galaxies and the radio galaxies, respectively. The spiral galaxies are conspicuous for their bright, young stars and earlier integrated spectra. The radio galaxies are emitting radiation due to the rapid motion of charged particles, an activity which would generally be expected to die down with age. As a result, the configuration of galaxies in these two panels looks very much like a giant spiral, with the younger objects out toward the ends of the arms. So here we have Figure 5.1. Radio galaxies in the Virgo cluster are indicated by filled circles. Well, that is pretty spirally looking. Symbol size indicates with optical luminosity in A, B, and C. Symbol size increases with radio brightness in D. The position of 3C273 had to be added as a plus sign in figure 5.1d because even though it was the most conspicuous quasar in the sky, astronomers insisted that its redshift placed it at 54 times greater distance in the background. A model for the Virgo cluster. The conventional explanation for spiral galaxies is that they are in equilibrium rotation and that a spiral wave runs around the disk, condensing the gas and forming new stars. This model is necessary in order to keep material spiral arms, as they appear to be, from winding up in circle after a few rotations. Only a few percent of the conventional age of the galaxy. This solution was proposed by a mathematician, C.C. Lynn, and quickly became fashionable. There are, however, a number of observational arguments against this model. I mean, this is so, I love his, he's so straightforward about things, like calling it fashionable, and that's just so true for what a lot of science seems to be these days. Just fashion. Either it's in or it's out. There are, not based on, deducing things from logic. There are, however, a number of observational arguments against the model. The IEEE Transactions on Plasma Science, volume PS14 from December of 1986, page 748. The alternative model is that material is ejected outward in opposite directions from the nucleus of the spiral, and either the ejection rotates or differential rotation in the disk draws the ejection track into a spiral form. I'll give that a highlight as well. Here we have figure 5.2, one of the brightest radio galaxies in the sky, 3C274, M87, and the brightest radio quasar in the galaxy. 3C273 are paired across the brightest galaxy in the center of the Virgo cluster, M49. Alignment is within accuracy of measurement. So, yeah, 3C274 and 3C273. The brightest galaxy at the center of the Virgo cluster, M49, is active. Its activity is attested to be its rather strong radio and X-ray emission, or is attested to by its rather strong radio and X-ray emission. If it had ejected some material roughly north-south in the past, and then had continued to eject it as it rotated counterclockwise for about 1/8 of a turn, we would expect a spiral pattern roughly like that observed for the spirals in radio detections in figure 5.1. What could have been ejected from the central galaxy of the Virgo cluster? I had stumbled across the answer in 1966 while finishing the Atlas of Peculiar Galaxies. Figure 5.2 shows that a line directly across M49, number 134 in the Atlas, roughly north-south, are the two brightest radio sources in the sky, 3C273 and 3C274 from M87. The improbability of this being a chance association was computed in 1967 to be about 1 in a million. Another one of those. Well, we got a lot of those. Perhaps even more convincing was the common sense question: is it significant that the brightest radio quasar in the sky falls in the dominant cluster in the sky and forms a pair with the brightest radio galaxy in the center, almost exactly aligned the brightest galaxy in the center of the, almost exactly aligned across the brightest galaxy in the center of the cluster? This result was published in Science in 1966 and Astrophysical Journal in 1967. It is incomprehensible to me how the field could have gone on believing quasars were at their redshift distances, even this one single result. More than 30 years ago, I'm going to highlight that as well. More than 30 years ago, astronomy took a gamble against odds of 1,000,000 to 1 that this observation was an accident. And so, yeah, let's actually highlight that as well. Here we go, everyone. Take a look at the beautiful artwork here in Figure 5.3. I believe that Shane has this one as his desktop background. And then Figure 5.4 here, also beautiful artwork. I believe Alan is getting this one put to print as we speak. So there you go.
Yeah, it's going to go on the mantle.
That'll look really good on the coffee table, right?
Going next to my Monte Cristo map, or Monty Python, or whatever it's called.
The Monte Cristo Python map.
I'm getting a beach towel made of Figure 5.4. So, lines of galaxies along ejection directions. In 1968, after the brightest radio galaxies in the sky had been identified, I just looked at the smaller galaxies in their neighborhood and saw them conspicuously aligned across the central galaxy. In most of the cases, this alignment coincided with the direction of ejection of radio material from the central galaxy. Published from the Astrological Society, Pacific 80, 129 from 1968. In a personal letter to me, Dave Vaucouleur said there was something very significant here, but he never could make the obvious step that the galaxies in the line had an ejection origin from the larger radio galaxy. I mean, that's too big of a leap, I suppose. In Figure 5 for him. In Figure 5.3, the line of E galaxies through M87, also known as 3C274 and Virgo A, is reproduced from the 1968 paper. It shows how the smaller E galaxies align along the famous blue jet discovered in 1918. In all this time, however, the obvious inference was never considered that the blue knots in this jet are connected with new emerging proto-galaxies. Figure 5.4 shows the distribution of the brightest X-ray sources in this region of the Virgo cluster. The same line is marked by the active X-ray objects. Interestingly, it turns out that the bright X-ray source at the west-northwest edge of the line of the jet is none other than the brightest quasar, PG 1211 plus 143, which we discussed in Chapter 1. As noted there, the object is non-operationally defined as a quasar, though it is really more like a high redshift Seyfert galaxy, Z equaling 0.085. And like so many Seyferts discussed in that chapter, it is ejecting quasars of a higher redshift with a Z value equaling 1.02 and 1.28. Thus, we have M87 ejecting a Seyfert, which in turn is ejecting quasars. We see a hierarchy of generation, the younger objects having increasingly higher redshifts. So here, Figure 5.5, 6 of the 7 brightest galaxies in this large region of the sky fall across the giant radio galaxy Centaurus A. Arrows mark the brightest radio galaxies in the region. Numbers refer to various Seyfert and active galaxies which fall along this line and which are identified in the text. Radio and X-ray jets in the center of Centaurus A are slightly rotated from this direction.
So I'm missing where he's assessing age to any of these in any fashion other than geometric spread. Is that where he's driving there? Geometric, like the arm width kind of thing, and distance from larger body is the only thing that he's using.
I think he's talking kind of
in
like,
association with the redshift, right?
Well, yeah, the redshift seems to be kind of inverse from what they expect, essentially. And it's, I think largely on what you said originally, right? Like just geometric position and where things seem to be spiraling to and fro and ejecting from. So it seems to be kind of just an inferred age based on that. That's what I was kind of collecting.
Yeah, bit of a leap of faith, but let's roll.
Yeah,
with it,
yeah.
please.
Oh, totally agreed. Totally agreed. Yeah, it's
Never
funny how
judge a galaxy by its spiral arms.
It's funny how he like knows that they're wrong about everything, but then still tries to like make a bunch of crazy assertions that are kind of based in the same premises. But I guess you got to work with something, I guess. But yeah, it is a little odd at times. So
like It's like
go
it's
ahead.
like he's mixing two. It's like he's mixing two fan fictions, and they're like, "No, dude, we're
Yeah.
doing straight Star Wars. You're doing Star Trek, man."
Yeah. So, pardon me. Returning to the structure of the Virgo cluster, it is very important to note that in Figure 5.1, the spirals form a hollow oval just around the line of E galaxies. Again, the experienced cataloger of the Virgo cluster, de Vaucouleurs, noted this, but generally assigned the spirals to a separate cluster in back of the Virgo cluster because they had systematically higher redshifts. We now know, some of us anyway, that the spirals have higher redshifts because they are younger. And what else could the hollow oval mean but that they had been ejected as proto-galaxies from the line of older E galaxies? Apparently, we see at least 3 generations of galaxies in the Virgo cluster, and if the few negative redshift galaxies are older still, then perhaps we have even more generations. So anyone else feel like reading? If not, I can keep going. All right.
Yeah, sure, man.
Oh, okay.
You want to go there?
All right.
Give it a shot.
Dude, you
Alan.
want
I'll
to
pick you up after.
flip for it, Stone? All right. Let's
Well,
go.
I got this nice
Rock,
shiny
paper,
mic. I wanted to
scissors,
make
go.
use of it. But you go and do your thing for a bit, and then I'll pick you off.
All right, cool. All right, so the Centaurus A line, one other radio galaxy, the nearest example to us, should serve to clinch this picture because it shows almost the same structure as the Virgo A. Figure 5.5 shows a large area of the sky, 40 times 40 degrees. 6 of the 7 brightest galaxies all fall in a line centered on the radio galaxy Centaurus A, which is the brightest. The strongest radio sources, marked by the arrows, fall along the same lines. Now, there is a well-marked radio jet in the interior of Cen A, given by NGC 5128, and in Virgo A, the strong X-ray jet coincident with the radio jet. That same reference shows that there is a continuous rotation of about 1/8 turns from the direction of the outer line of the galaxies and the filaments to the direction of the inner jets. This is just about the inferred rotation of the ejection of M49 at the center of the Virgo cluster. Redshifts in the companion galaxies along this line vary from about the same as the central galaxy to about 4,000 kilometers a second or higher. As Table 5.1 shows, there is a number of Seyfert galaxies along this line which have a higher redshift. The quintessential example of IC 4329A, number figure 3 in figure 5.5, which is a very strong X-ray source. This Seyfert companion is IC 4329, a brighter E galaxy with 560 kilometers a second lower redshift. IC 4329A is it has identified quasars and candidates around it awaiting redshift measurement. Here we have here we may have a replication of an ejection of M87 of a Seyfert.
Yo, sorry, my arm hit
Good.
my space bar.
Okay, where were we at?
PG 1211.
I think we were up a little bit, weren't we?
There you go.
Yeah, right around here. PG 1211 143, which in turn is injecting a pair of X-ray quasars. In Centaurus A, again, we have 3 generations of galaxies increasing intrinsic redshift as they get younger. There are not any negative redshift galaxies in the Centaurus region. However, the group seems to have a higher percentage and of a higher redshift of the objects than in the Virgo. Therefore, we might consider the proposal from Centaurus A was ejected, that the proposal that Centaurus A was ejected from the part of the evolution of the Virgo cluster. Centaurus A in the close plane of the local supercluster and only 53 degrees south of the supergalactic longitude, our own local group of galaxies and other nearby bright galaxies lie close to the same plane and might be associated with Centaurus A. They might share a common origin from the center of the superlocal cluster or the Virgo cluster. The center of the Virgo cluster. If the structure of the Virgo cluster is mostly determined by the ejection from the table below and a graph The central galaxy M495 or M49, we might wonder whether it is running down or it is in a quiescent phase. However, while it is true that M49 is not a strong radio X-ray source as M87, it is still true that M49 is a fairly active galaxy in these wavelengths, and some continuing activity might be expected. It is to be noted in Figure 5.1 that M49 appears to have most of the small retinue of the spirals to the northwest. Retinue. All right, if we look for quasars of the youngest objects we can identify, we find the intriguing situation pictured in 5.6. The left-hand panel shows that all of the cataloged quasars in the area. Just as the most experts would expect, there is a random appearing group of points. But if we plot the brighter quasars in the 1/2 magnitude interval between 17.4 and 17.9 mag, magically, the line appears of the quasars emerging from M49. Oh, no way. The apparent magnitudes turn out to be an indicator of distance. We will continue to see if there is something useful in this respect, particularly considering that the redshifts are such bad indicators of distance. The redshift in the line do have an intriguingly close correspondence to the preferred peaks of z equals 0.30, 0.60, 0.96, 1.14, and 1.96, of which we will have more on to say later. Also, there are some numerically very close pairs of redshift. One should look in the opposite direction of the long quasar line. Quasars emerge from M49 in the northwest direction between the position angle PA equals 310 minus 320 degrees, but at about 180 degrees opposite at PA 140 degrees, there is a disturbed dwarf galaxy, UGC 7636. This is the clue that caused me to point out that M49 in the book, The Atlas of Peculiar Galaxies, as number 134, midway between M49 and the dwarf is the hydrogen cloud, which Jimmy Irwin and Craig Sarzan argue is so massive that it must be mostly in the form of molecules. I would infer that something must be flung out or entrained in the opposite of the injection of the quasar in the typical pairing patterns that we have to look through this book. It is also fascinating to note that the redshifts of the aligned quasars tend to decrease as they increase their distance from M49. This behavior is shown in the form from the composite of the quasar association in Figure 9.3 and so dramatically confirmed by the Seyfert in Figure 7.9. Quasars in the Virgo cluster. These quasars are not supposed to be there, which makes them a very delicate subject. But 3C273, the brightest quasar in the sky, was shown to belong to Virgo. Oh yeah, that one definitely. Can you scroll up a little bit? That one definitely looks like it belongs to Virgo. There's the old galactic longitude, latitude. Up one. Clusters in 1966. Only 3 years after the discovery of quasars, in 1970, it was shown that in the northern hemisphere, the brightest radio quasars were associated with the brightest galaxies, which naturally defined the Virgo cluster. Then, the objective prism search for the Virgo cluster turned up new quasars, which the brightest of which were associated at the probability level of about 1 in 10,000, Figure 5.8. Next, a survey over the northern sky of all the bright quasars picked by their ultraviolet colors. This survey was performed by two stalwart believers in cosmologically distant quasars. Yeah, Martin Schmidt and Richard Green. They failed to notice that the bright quasars were unmistakably concentrated around the Virgo cluster. Jack Solonick, shout out to that guy. performed a careful analysis in 1988, and the results are shown in Figure 5.9. See, this is the primary observational data simply cataloged positions of the quasars, just photons as a function of x and y, and yet it seems that they have made no impression on most astronomers who insist on believing that quasars are evenly spread out in far reaches of the universe. Magnetic fields of the local supercluster. Another proof of the quasars embedded in the local supercluster came in 1988, at the same time it was furnished valuable information about the intergalactic medium in the cluster. Little note from Faraday rotation. The polarized component of the quasar's radio emission rotated as it passed through the magnetized plasma. The rotation of the plane vibration of the photons is called Faraday rotation, and it is proportional to the amount of plasma traversed. Very cool. Stone, do you know anything about my boy Faraday plasma in your plasma searches?
The guy and a lot of his EM research, yes, but not that he was into astrophysics. No, this is a new one on me. That's pretty cool. Nice factoid.
Cool. All right. Since quasars were supposed to be the most distant objects known, it was of an interest to see whether the polarized photons showed evidence of having traveled through a magnetized plasma on their voyage through the extragalactic space. Ooh, a little medium interaction there. Japanese astronomers led by Y. Sofu showed in 1968 that this was indeed true. Sweet. Extra intergalactic medium, boys. That's what's up. After a careful correction for Faraday rotation due to the passing through the various paths of our own galaxy, Philip Kronberg and Judith Perry produced a list of 115, which of the subset of 92 are plotted here in Figure 510. At first, it was claimed that the mean absolute value of the Faraday rotation increased with the redshift of the quasar. That led to an exciting conclusion that the distances to the quasars could be measured by their mean of Faraday rotation. Then disaster. Oh no, it's going to fall apart. The mean rotation of the quasars, z equals 2, instead of being twice as much of the quasars around z equals 1, was only about 1/3. Oh no.
But disaster.
So unfortunate. What a disaster! But what was a disaster for the conventional redshift distance was just about the local quasars required. So their model fell apart, but your boys' redshift quasar model is hanging strong with what is it? Slow cooling matter producing intrinsic redshift. Very cool. Let's see. Examining figures 5-10 reveals the major feature that the large Faraday rotation of the quasars is just about z equals 1. That fit is exactly the findings in Quasars and Redshifts and Controversies, page 67, where it is shown that around z equals 1, the quasars have their highest luminosity and therefore can be seen at the greatest distance. High rotation for a few of the z equals 2 or greater quasars is probably due to the dense plasma or dust cocoons around these proto-objects. So the Faraday rotation can measure distance. They just confirm unfashionable distances. Unlucky. Let's see, since we can see that z equals 1 quasars furthest, or since we can see the z equals 1 quasars are the furthest, and they are associated with the galaxies at the distances comparable to the Virgo galaxy cluster, galaxy. Let's see. It would be interesting to see if the z equals 1 peaks comes out to any particular part of the sky. Amazing. The open circles in Figure 510 show that they come from the direction of the local supercluster. The editor in Nature believed that the referees when they said that I had cooked the data and that the observers lost interest in the subject when I did not give the expected answers. Actually, there was quite a bit more in the data than the distances. Figure 511 shows that the quasars between 0.7 and 1.1 are plotted over a region of the North Galactic Hemisphere, and they can readily One can readily see their concentration around the Virgo cluster. Moreover, the circles enclose the negative values of the Faraday rotation, and it's evident that the Virgo quasar show predominantly large negative rotations. This is exciting because it means that the magnetic fields which is causing the rotation is not alternatively one way and then the other, but is dominantly in one direction. We have discovered a symmetrically orientated magnetic field in the supercluster center. Dang, that's pretty cool. And even it is possible to estimate the strength of the field as the field B equals 3 times 10 to the minus 7 Gauss or greater. Very cool. This is only a little less than the magnetic fields measured in the galaxy over the distances of or more than 2 orders of magnitude or greater. The values of 100 million times or larger. This finding will have a particular interest for when this finding will have particular interest for us when we show or when we shortly consider the extended high energy radiation in the gamma cosmic rays, which is coming from us at the center of the local supercluster. It is apparent that the high energy quasars, which are embedded at the supercluster, are injecting into the magnetized intercluster medium. Further evidence of the distance of 3C 273. In 1989, Riccardo Giovanelli and Martha Haynes announced the discovery of a very peculiar hydrogen cloud in the Virgo cluster. Like everyone else, I had heard rumors about this, but Jeff Burbidge telephoned me and told me that it was only about 3/4 of a degree from 3C 273. I was therefore very interested to attain the colloquium given by Riccardo. The ECO shortly thereafter. When he flashed the map, he pulled up that map piece, boy, showed that cluster. When he flashed that map out of the screen, I gasped. The cloud was so long and narrow, and it pointed directly back at 3C. I pointed this out, and there was a moment of silence. Then another member in the audience rather sarcastically asked, Where does the jet in 3C 273 point? It points right down in the it points right down in the cloud, I replied. There was never any longer moment of silence. Boom, just dunked right on him. Very nice. I hurried back to my office and plotted the position for 3C and the jet on the Xerox of the cloud that Riccardo gave me. The line of the 3C jet lay 3 degrees off the axis of the cloud, even closer than I had visualized. And the chance that the cloud accidentally pointed back at the same direction as the quasar times the improbability of the jet pointing down in the same line was negligible, of course, but these were both unique objects in the sky. But the immediate importance of this result lay in the fact that the redshift of the cloud was z equals 1,275 kilometers a second, about the redshift of M87, and therefore everyone agreed a member of the Virgo cluster. If the cloud was connected to 3C, that meant that 3C was in the Virgo cluster. Figure 512 illustrates the symmetries involved in the Virgo cluster. First of all, there are symmetries of 3C and 3C 74. It's the sister of 73. So close to the sky that they have become successive catalog numbers and align across M49, which is associated with NGC 4472. Then they both have the most conspicuous optical jets of any objects in the sky, both almost exactly 20 arc seconds long, both along the line of M87. Vin's jet is a radio galaxy with a swept back radio X-ray isotopes, indicating that the motion out of the line of the jet. C373 out of the lines of this jet is a hydrogen cloud like track that something is passing through. The differences are also interesting. There are more older, lower redshift objects in M87 on the M87 side of the cluster, while on the on the 3C73 side, the objects have a higher energy spectra and higher energy higher redshift, as if they are as if the side represented a retarded version of the M87 wing. That's interesting. There are also small radio sources and X-rays, and X-ray sources are so obviously associated with the jets of 3C, which 73, which should be systematically investigated. Jeff and I published the material on 3C73 and its jets and its jets in the cloud and the astronomical journal letters, and I spoke my mind on the subject of Patrick Moore's popular magazine, Astronomy Now. But basically, that ended the matter. It was not ever considered in conjunction with all the other evidence that is gathered together here on the local supercluster. One major point of this present book is to make it impossible to ignore the enormous amount of mutually supporting significant evidence which points to the same conclusion. That their model's wrong, right? I think that's what he's getting at.
I mean, yeah, that they fundamentally misunderstand Redshift, yeah. Now this one, could see a nice little animation, make a music video. Sorry.
Actually, I'm actually getting that tattooed on my back.
There you go.
Perhaps some color. Ooh. Dare I go so far?
I think that would kind of impede on the artistic integrity a little bit.
Yeah, I'm actually getting it done in black and white to be true to its original print, the text. Getting full prison tat.
Or we could go, actually, yeah, and we could do tie-dye with it. Like a nice tie-dye. Maybe a little bit of glow in the dark. All right.
Oh, yeah. All right, Stone, you want to tag in?
Sure thing. Let me get back to where I'm at on my doc. Latest statistical association.
Yes, sir.
I was just checking it ahead to see how much we have left. The latest statistical association of quasars with Virgo. In 1995, the Chinese astronomers Zhenfen Zhu and Yao Quanchu analyzed the light bright quasar survey in the region of the Virgo cluster. Figure 513 shown here is taken from their work. It illustrates beyond doubt that the 178 quasars clearly fall closer to the cluster galaxies than they would at random, but are not correlated with the background galaxies. For statistic fans, the confidence level reaches as high as 7.7 sigma in some intervals. It would seem very hard to refute evidence such as that shown in Figure 513. These are quasars cataloged by someone else versus galaxies cataloged by still another party. The member and non-member galaxies had been determined previously, and exactly the same correlation program was run on both categories of objects. Because the region is so crowded with galaxies, it is difficult to recognize the individual pairings with quasars more than about 20 arc minutes separated from their parent galaxy. So an important additional result was obtained by these authors in correlating different apparent magnitude quasars with different apparent magnitude cluster galaxies. They found that the more luminous and massive the galaxy, the more numerous the quasars in its vicinity. And on the other hand, the brightest quasars were the most separated from their galaxies. Both of these results agree with the analysis of the Seyfert galaxies reported in Chapter 2. This is totally what I told ya! But their results also provided evidence against one of the cherished bastions against quasars being physically associated with nearby galaxies, namely gravitational lensing. They pointed out there was no association at very small separations where lensing is most favored. Of course, the wide separation of the bright quasars is much too large for gravitational lensing. These two astronomers have demonstrated enormous skill and integrity in dealing with not only the correlations present in quasars, but also the periodic nature of their redshifts. I will leave it to the reader to guess why the version of their paper which appeared in the European Journal of Astronomy and Astrophysics, unlike the version which appeared in the Chinese Astronomy and Astrophysics, did not contain the criticism of gravitational lensing. Yes, leave that to us, buddy. Only the unqualified should consider that. X-ray analysis of the Virgo cluster. In 1993, a group of X-ray astronomers from the Max Planck Institute for Extraterrestrische Physik mapped the X-ray photons received from the area of the Virgo cluster. They published the result in the prestigious journal Nature. It was a very nice paper showing the whole cluster was filled with extended X-ray emission, which they interpreted as a hot gas. One of the diagrams from that paper is shown here as figure 514. I have only added one thing, a label showing that the strong X-ray quasar southwest of M49 has a redshift of 0.334. They had identified this object in a previous figure as a quasar and mentioned in the text that there were some background quasars in the field. But in this figure, the quasar just sat there with at least 4 X-ray isophotons streaming eastward and connecting directly to the central M49. Everyone who read that article in Nature could see that there was a line of X-ray photons connecting this quasar at 100 times the redshift of the Virgo cluster back to the central galaxy of the cluster. What could cause an unrelated background object to behave like this? And all the astronomers involved certainly had heard about the evidence that just these kinds of quasars physically belonged to the Virgo cluster. What was the most significant aspect of this publication? I saw this picture in its early stages of preparation and was galvanized by an even more exciting implication. The X-ray emission running down the spine of the cluster was heading more or less southward toward the most famous quasar of all, 273, which I knew to be just below the cutoff of the picture frame. I tried to promote a southward extension of the map, but got no response. So I asked if I could use the ROSAT survey observations that went down into this area. The authors were very obliging and transferred the data into my computer files and gave me a copy of the program they had used to smooth the individual photons into the isophotons of the extended X-ray emission. Using the same program as they had on the upper part of the cluster, I produced the southward extending map shown here in figure 515. There was one slight difference in that the X-ray radiation got harder, higher energy, as it went south. So instead of using 0.4 to 2.4 kiloelectron volts, as they had done, I used 1.0 to 2.4 kiloelectron volts energy photons. But I was extremely pleased to see that my ISO intensity contours joined exactly on to theirs. One can see in figure 514 and 15 how the individual features continue across from their map to mine. And of course, there was 273 sitting right on the end of a strong continuous filament connected right back to M49. If you were to have a little look at those Rorschach tests right there. I don't know quite how to describe the reaction I got to this picture when I showed it to some of my colleagues. Perhaps it was like people viewing a grisly automobile accident along the highway, but I had a plan. I knew the upper part of the Virgo X-ray map would get published eventually. I just sat on the map of the lower part until that publication. It took a long time, but when it finally appeared in print, I pounced. In the letter of submission, I emphasized to the editor of Nature, John Maddox, that since I had used the same ROSAT survey data and the identical reduction program, if their just published picture was valid, then mine must also be. What a plan. The editor simply sent me back 2 referee reports, one more arrogant than the other. I thought, surely I could get it published in Astronomy and Astrophysics, and revamped the text to make the result less jarring. 3 referees turned that down. The kindest one suggested that I take it to the experts who had produced the upper Virgo map so they could explain to me what I had done wrong.
Dude, what?
That's some serious ass gaslighting by a third party if I've ever
That's
seen
hilarious.
it. Oh my God.
That was the kindest one.
All right. In view of all the other evidence known to show that quasars and 273 in particular belong to the Virgo cluster, I gloomily came to the ironic conclusion that if you take a highly intelligent person and give them the best possible elite education, then you will most likely wind up with an academic who is completely impervious to reality.
Yeah,
Somebody
can I get
out
that
the
framed on the
chisel.
wall?
We need to
Yeah.
print that in some stone and knock it up. We call it the new Georgia Guidestones of Astrophysics. All right. My X-ray map was finally published in the Physical Letters A203, 161, and in the proceedings of the IAU 168 Symposium. In the latter, it was presented in a panel discussion that so irritated Martin Rees. From the symposium, the popular magazine Sky and Telescope picked it up and published a simplified contour diagram, which is shown here in 516. It is interesting to note that the picture I published in the professional journal emphasized the continuity across the independently measured connecting features so that the viewer could verify that they were real. In the popular journal, they assumed that the reader recognized the physical significance of this line of X-ray emission and instead emphasized the identification of the important objects which were connected together. Oh, nice. Gamma rays in the Virgo cluster. The situation took on added poignancy when the observations from the High Energy Gamma Ray Observatory, the GRO, started to be processed in an adjoining building. Photons of from thousands to millions of times the X-ray energies were expected to come from only the interiors of the densest, most active extragalactic objects, yet they appeared spread out over the Virgo cluster. Worse than that, these extended gamma ray emissions appeared to connect together quasars of different redshift in the cluster. A young researcher in the gamma ray division showed me these maps, and we agreed they looked real. The problem was that the senior members of the group were trying to make these extended features go away by elaborate processing techniques, which essentially just consisted of high-cutting the data. Of course, I knew that these observations corroborated and extended the X-ray data in Virgo. It was very painful for us to see this extremely important data withheld. Sounds like the LIGO boys, yo.
Yeah.
Yo.
Sounds
Ay,
like
ay.
Miller, too.
Yeah, indeed, millions of Millers. Naturally, we could only deal with published data, so it was good fortune to find a published map of Virgo in the low-energy gamma rays in the proceedings of a meeting held in March 92. That map is shown here in 517. It is clear that 273 with a redshift of 0.158 is linked to 279 with a redshift of 0.538. In the first chapter, Fig 112 showed how unrelated sources would meld together, and it is clear that the very elongated isocontour lines between two quasars in 517 represent a real physical connection. The quasar 279 is violently variable and was, from the Harvard Patrol Camera records in the early 1900s, once one of the brightest apparent magnitude quasars in the sky. Like 273, then, it is reasonable that it would be associated with the largest aggregate of bright galaxies and radio sources in the sky. It is classified as a blazar. Whoa, like you got your lighter on full, dude? You blaze with it, yeah? Raw. And is one of the brightest gamma ray sources in the sky. Of further interest, in Figure 517 is the extension of these Comptel gamma rays upward toward M49 and M87 in the center and upper part of the Virgo cluster. To make a preliminary summary of the data, it seems that X-rays in the 0.1 to 1 keV range extend in either direction from the central M49 to M87 and 273. As they near 273, they become more conspicuous in the 1 to 2.4 kV range. From 1 to 10 mega electron volt, 1,000 times more energetic, the 273 and associated material is most conspicuous. From 10 to 30 mega electron volts, 273 begins to drop and 279 begins to dominate. This trend continues with the gamma ray telescope on GRO, which measures the highest energies from 100 mega electron volts to several thousand mega electron volts at the egret. There is a clear progression in the lower energy radiation from the older, lower redshift galaxies to photons of higher energy from the younger, higher redshift 273 and continuing to even higher energy for the most active, highest redshift 279. It is important to consult the original reference for the Comptel map shown here in 517. And in the Astrophysics of 1997, 2 revisions, and 4 years later, the 26 authors had been reduced to 13, and the observations had been selected and processed in such a way as to show no recognizable connection between the 2 quasars of different redshift. But fortunately, there was another, more sensitive instrument mounted in the satellite GRO. Oh, thank God for that, eh? Let's do it for satellites. Highest energy gamma rays from the egret. In the group at MPE processing the observations of gamma rays from 100 to greater than 1,000 mega electron volts was the aforementioned Hans-Dieter Radeke. Without knowledge of results in any other energy bands, he pointed out the extended gamma ray emission in the Virgo cluster, and particularly the gamma ray extension joining the 2 quasars 273 and 279. There were 2 reasons why this news provoked great agitation and disapproval. First of all, it placed 2 quasars in the cluster which officially were supposed to be unrelated to, I guess, each other, and at enormous distances behind the cluster. Secondly, it required these very high energy photons to come not from dense energetic cores of cosmic objects, but to radiate from extended, presumably low density regions. The researchers were expecting point sources, and when they saw radiation obviously spilling over into extended regions, they immediately became apprehensive that their instrument had inadequate resolution and/or uneven background. Considering the cost of the project and future funding, that could understandably cause quite a bit of anxiety. Moreover, there was very little experience at MPE with low surface brightness astronomical features. The reduction algorithms were designed to detect point sources, and they did that very elegantly. However, I noticed in my own work with the standard data processing programs that even conspicuous, even slightly extended sources were often not detected. Since I had done some of the earliest work on low surface brightness features with the Palomar 48-inch Schmidt telescope, I tried to convince people of the value of such investigations. But there was only work on objects that were supposed to be extended like galaxy clusters and supernova remnants. As a result, there's a goldmine of data in the archives on galaxies and quasars waiting to be investigated for extended emission. Radeke encountered strong opposition by some in the group, reluctance and disinterest from others. Nevertheless, he went ahead to try to test the myriad reasons advanced by his colleagues as to why the apparent extended material could not be real. In one test, he painstakingly computed the time variability of the photons in the image pixels between 273 and 279. He was able to show that the bridge stayed constant while the quasars varied strongly in intensity, thus scotching the argument that the bridge was spillover light from the quasars. He even determined a spectrum for the connection, which was manifestly different from that of the quasars. Of course, anyone could tell the bridge was real just by looking at Radeke's picture as shown here in color plate 518 in our full splendor non-color copy here. The bridge is long and narrow, and one can easily visualize that it could not be caused by 2 overlapping circular distributions as in figure 112. It is also extremely important to note in plate 518 that this high-energy gamma radiation extends from the center of the Virgo cluster, declination about 8 degrees, down to 273, and weakly in the other direction to M87, declination about 12 degrees. This confirms the conclusion advanced earlier that high-energy objects arise in the center of the cluster and extend outward in opposite direction, but that the extensions to the south acquire increasingly higher energy. It should be remarked that the observation pictured here in 518 was taken when both quasars were in a low state, particularly 279, which was only 5% of its maximum luminosity in the 3 observing periods. This fortunate circumstance enables us to see the extended connections particularly well. All right, time for some gamma ray games. No whammies. No whammies. Of course. There was a desire to announce important scientific results from this satellite telescope, so the detection of some known energetic point sources was publicly released. I remember the jolt I received on reading the December 92 sky and telescope. There in false color was the gamma ray map of 279. Trailing off to the northwest was this extension of gamma rays, of which nothing was said in the text or figure caption. I immediately made an overlay to verify the position of 273 at the end of the bridge. Then I copied off the contours from the color picture and produced 518. Even with 279 at its bright phase, the connection to 273 showed very well. Are we to believe that the people who released this picture did not know 273 was there? Sometime later, I organized a one-day colloquium in honor of the simultaneous visit of Fred Hoyle, Giant Naligard, Margaret and Jeff Burbage to the Garching Institutes. I invited the MPE group to present some of their material with the dual idea of airing a little mass creation physics and getting a little discussion going on the gamma rays in Virgo. But they simply presented point source statistics, and I had to show the connections shown here in 517 and 18. Radicus map plate 518 was not yet completed. A younger member of the group spoke up from the audience and said further observations show those features are not real. There were knowing looks in all around, and all I could lamely say was, well, I'm only able to show the meager data in the literature, so in view of the importance of the point, I think all data should be made available. After that, I made a point of attending gamma ray talks at the institutes, where they would always present the picture of 279 with the trail of emission going off to the northwest and make no comment about it. No one else said anything. I had long ago learned that colloquia were events of intense social pressure, and that comments from the floor which questioned the assumptions of the speaker and were not explainable in a few sentences were neither understood nor welcome. After the Retica map shown in 518 became available, however, a change took place. I attended a presentation to a large audience by the leader of the gamma ray group, and when he projected the usual picture of 279, I could tell that the bottom half of his transparency contained the picture where both quasars were at minimum, and the connection between them was blatant. Aha, I thought, this audience is now going to see the inescapable truth of the matter. But after he was through discussing the top half, he quickly whipped the transparency off the projector. I suppose he and I were the only people there who knew what was on the bottom half of that transparency. Wow.
So sad, dude.
With a tremendous effort, Radicke finally finished the enormously detailed analysis of the Virgo cluster gamma rays, and after many delays, the group reluctantly permitted him to submit it for publication. It was clear by then that he would not be rehired at the imminent end of his contract. Been there, man. After about 10 weeks, it came back from the appropriate journal with a rejection from a referee in competing gamma ray group. It was then sent to another journal, and more than 2 years passed before it finally appeared in Astrophysics and Space Science. After exhausting all possibilities, he was about to go on unemployment when the director of the institute where I was a guest came to the rescue. For 6 months, he was hired to process the archival X-ray observations around Seyfert galaxies. This was the project described in Chapter 2 under the title Seyfert Galaxies as Quasar Factories. The project was such a spectacular success in establishing the physical association of high redshift quasars with the low redshift active galaxies, thus disproving the whole current basis of extragalactic astronomy, that we felt sure it had rescued his future. I felt this project, plus his knowledge and dedication to the spirit of research, made him the most desirable appointment to a research position of any person I had seen in decades at any level. But the process of publishing the Seyfert results dragged on and on. We held a little celebratory lunch when the papers were finally accepted. and the publication of his gamma ray results in the Virgo cluster were still not accepted, much less published. Finally, his unemployment money ran out, and he had no choice but to change to a career of technical science writing. Well, it beats tricking, so good on you. Ultra high energy cosmic rays. I mean, no one wants to be a hoe, let's face it. About the time our hopes of convincing people at the institutes of the importance of X-rays and gamma rays in the Virgo cluster were fading, I noticed a development in the journal Physics Today. I don't know how many people are aware of it, but there is a dedicated group of experimental physicists who measure cosmic rays from ground stations in various parts of the world. These cosmic rays are the most energetic radiation we know, some particles generally changing from iron nuclei to protons at energies of over 10 to the 19th electron volts reach about 100 million times higher energy than the gamma rays we've just been discussing. They produce air showers of secondary particles with some difficulty and are made to yield the arrival direction of the primary particle. The article in Physics Today noted that after much data collection, it had been found that the highest energy cosmic rays were coming from the direction of the supergalactic plane and from the map of events, mostly from the supergalactic center. One set of measures is pictured in Stan Evanel 1995, Physical Review letters, yada yada. Another one here in 519. The existence of such high energy radiation had not gone unnoticed by theoretical physicists and astrophysicists. They doubted that the usual methods of cosmic ray production would give energies that high. Some speculation was forthcoming concerning primordial matter. This was a shocking suggestion, considering that in the prevailing Big Bang theory, all primordial matter had gone bang 15 billion years ago. Moreover, the ultra-high energy cosmic rays were calculated not to have an origin at greater distance than about 30 megaparsecs because of scattering off photons in the cosmic microwave background. That meant they almost had to come from the center of the local supercluster within about 20 megaparsecs because this is the only significant concentration of material inside that distance. Empirically, my favorite adverb in any science, we had bright quasars, sources of huge amounts of X-rays and gamma rays sitting right in the Virgo cluster, and they were the only possible connection to the ultra-high energy cosmic rays. Yet their redshifts, on the conventional assumptions, ruled them out as residing in the Virgo cluster, a theory that explained why their redshifts were intrinsically high because of recent origin from energetic primordial matter in the cluster would seem to solve everybody's problem. Will a theory help? Rhetoric will get you nowhere, buddy. In 1993, Giant Narlikar and I had published a paper outlining how newly created matter will have a high redshift and demonstrated how to account quantitatively for quasar and galaxy redshifts as a function of their age. See chapters 4 and 9. In this chapter, we have spent some time giving the evidence that the powerful quasars and radio galaxies are all young objects taking part in the evolution of the Virgo cluster. But there had been no specification of how, i.e., in what form the low mass matter was created. Was it electrons and positrons? Hydrogen atoms? Yeah, keep guessing, buddy. Also in 1993, however, Fred Hoyle, Jeff Burbidge, Giant Nauticon introduced the quasi-steady state cosmology, QSSC. There, they created the matter in form of Planck particles. The mass of the present-day Planck particle is about 10 to the 19th giga-electron volts over the square of the speed of light, whatever the hell that's supposed to mean. In the short time scale of about 10 to the negative 43 seconds, the particle is unstable and decays into baryons and mesons. You guys know how short span of that piece of time. That's 0.043 zeros and a 1 on the end.
Science, bro.
Of a single second. for the decay time. Did anybody measure that?
Well, no, Stone. It's about 10 to the negative 43.
Oh my God. Okay, if each particle, for example, decays into 1 billion particles, then each will have energies of around that of the observed UHCR. I had long urged Giant to create these Planck particles at zero mass and let them grow with time, which is also totally nonsensical to me, but let's not go there. That would solve the energy and redshift problem simultaneously. Finally, we got together over lunch in Sri Lanka, where we had gone to a UN-sponsored dedication of a new telescope in the Arthur C. Clarke Science Center. The scene in the movie 2001, where the ape threw a thigh bone he was using as a tool up in the air, and it turned lazily over and over until it suddenly transformed into a space station orbiting the Earth to the strains of a Strauss waltz. That scene for me was an unforgettable, emotional encapsulation of the potential of humankind. When the author of 2001 later wrote me an enthusiastic letter about my iconoclastic book Quasars, Redshifts, and Cosmos, I was thrilled beyond expression. And we know who that author is, don't we, gang? In spite of my unease at the Tamil rebellion in Sri Lanka at the time, I could not resist flying to Colombo to talk to Arthur Clarke and at the same time discuss Planck particles and redshifts with Giant Narlikar. As the lunch was ending, we found a piece of paper, and he sketched out, simply enough so I could understand it, the diagram which I've copied here in figure 520. This simply illustrates that a single Planck particle has enough energy so that its breakup could supply enormous numbers of ultra-high energy cosmic rays. The evolution path at the bottom simply specifies that in the language of particle physics, the Planck particle is created in the quantum gravity area, rapidly breaks up, and goes through the symmetry breaking of the grand unified theory. And the resultant individuated particles then proceed into the electroweak area. How might this be applied to activity in the center of the local supercluster can be outlined as followed. The emphasis on can. Newly created material in the centers of active galaxies and quasars is ejected outward in the ubiquitous jets and pairs which are observed. The material starts out with the velocity of light, but slows down as its rest mass grows. The decay products of the Planck particles, like the baryons, electrons, don't get those positrons, will show a similar behavior. The energetic particles will penetrate and be diffused in the intergalactic medium of the cluster. As we've seen earlier, this medium is to some extent magnetized and will wring Bremsstrahlung, if you can believe that, and synchrotron energy out of charged particles, particularly low-mass particles. When particles are sufficiently evolved to form atoms, spectral lines produced in transitions would be redshifted, but probably not much more than the observed range in redshifts of active galaxies and quasars which currently defined the cluster. What advantages does this model offer? Besides a fabulous plush interior, it identifies a range of the strongest high-energy radiation in the sky as coming from the unique aggregate of active objects, the local supercluster. It attributes the energy to ongoing matter creation, a process which replenishes the unavoidably rapid decay of radiation of such high frequency over a very short, compared to cosmic, time scale. Since the newly created matter has initially high intrinsic redshift, the younger, higher energy density quasars and radio galaxies are allowed to be in their apparent location in the Virgo cluster and are naturally identified as the principal contributors to the high energy radiation in the local supercluster. The extended distribution of the X-ray and particularly the gamma ray radiation in Virgo would be a natural consequence of recurrent injections into the intercluster medium. That's kinky. A small epilogue. my ever naive plan to win some attention for the observations with this theoretical suggestion was greeted by remarks like, well, the gamma ration looks like background irregularities to me. And the proposed mechanism for the energy is wildly speculative. From this, I conclude that the suggestion that the high energy radiation comes out of nothing is less speculative. Okay, the reaction around my own institution was so shocked that it was deemed better if I had to submit it for publication for me to use my home address. That was all right with me because I was so grateful for the friendly support and invaluable office facilities that I genuinely did not want to repay my hosts with embarrassment. But I had to laugh when I thought about sitting in Arthur Clarke's office reception in Colombo. I wanted very much to bring him some important, not yet known scientific development, something that would surprise and delight him. So when he asked, "Wow, what's new in astronomy?" I pounced. There are extremely high energy cosmic rays, gamma rays, and X-rays coming from the center of the local supercluster. I paused to let that sink in and prepared to issue the astonishing and exciting explanation. Oh, yes, he waved his hand in the air airily. Matter creation. I sat there with my mouth open while we went on happily to other subjects. It has slowly percolated, though, through to me since then that there is a world of difference between the imagination of a good science fiction writer and the average professional scientist. And that's chapter 5, boys.
Much appreciated, Stone.
That's an
Nice
interesting closing paragraph there. I wonder how many, like, there actually might be a high ratio of alternative cosmologists that are science fiction people that read science fiction, you know, because they're able to kind of imagine alternative cosmologies. That's a pretty good chapter overall.
I saw a lot of fishing.
Oh, yeah, I mean, I don't agree with everything he has to say, but certainly can relate with a lot of it. As far as dealing with censorship and not being taken seriously. Whoops. Thanks, Alan. Thanks, Stone, for reading. That'll wrap it up on Seeing Red for this week. Anyone have any final thoughts or questions before we wrap things up here? Toby, where can I get the best? What's up?
So yeah, do that right after this comment. I was just about to say, Toby, I remember you in the main chat text a couple of days ago, probably a week and a half now, mentioning Master Evo's latest video on electrostatics and that you wanted to hear what I was thinking about that. So I've sat down twice with that video and typed out a few things. It's come to all of 2,800 words now. And I'd like to read my thoughts out to the gang, but not as a part of your stream here because it's off topic. So maybe we'll wrap this and we could kind of, I don't know, segue to that at your convenience tonight and see what you guys think of what I find.
Yeah, that's cool. If you want to do that, I'm down to do that right now. If you want to give me like 5-10 minutes to close this stream and then start that stream.
Yep. That sounds
cool.
good. I'm going to get a drink too. Good thing.
Cool. All right. Well, let me close this out then. And yeah, so I'll just go ahead and wait. Hold on, Toby. Hold on. I have a question. Where can I get the best coffee with a penguin logo on it? I love penguins and I love coffee. Oh, I don't know who asked that. I didn't see anyone. I only saw I saw myself hot miking. I didn't see who was asking that here on Discord. But to answer your question, you could go to brushtailcoffee.com or brushtail.coffee. That's BRUSHTAIL.COFFEE. And you could order coffee from there, and you could pick from a bunch of different origins. If you don't know anything about origins and wet versus dry processed coffee, just go to the dry process section and grab yourself the Ethiopia Yirgacheffe. You can't go wrong with that. Also, the Honduras 18 Rabbits is a very popular pick, and that won't last very long, so grab that. And, or you can go subscribe, and then you can just get coffee sent to yourself regularly at an interval that works for you, and it's always roasted small batch myself on my grill with a special drum contraption. I can't talk. And then I roast it there myself, and then I always ship it fresh. So when you order, it may be roasted within a couple days, and then as soon as it's roasted, it's immediately shipped. So you always get coffee that's roasted within a week, which, in my opinion, is a lot different than coffee that you get from the grocery store, where it has a best by date rather than a roasted on date. So there you go. If you want to support Brushtail Coffee or just drink good coffee, you can do that. Also, if you want to support us here at Ether Cosmology, you can go to support.ethercosmology.com and support us that way. So anyways, tomorrow night, so tonight was reading night. We do this every Monday night at 9 p.m. Eastern. I put out a promo earlier and accidentally said 8, but it's 9 p.m. Eastern. And then on Tuesdays, we do presentations / roundtables. Tomorrow will be more of an open discussion roundtable, but with a small bit of presenting on the topic of the constants in physics. So if you have any interest in that, be sure to check that out on our Twitter or on our YouTube or Rumble. Or also you can come listen in live here on the Discord server, because that's where we typically do our presentations. So yeah, check that out. And then check us out on Thursday night for an open discussion, either over on X Twitter Spaces, or every now and then we do them over here on the Discord server. So check that out. And thanks again, everyone, for listening in with us and for reading with us. And